All right, welcome back to pre-calculus. So we're talking about hyperbolas here. So this is one of those problems where it's got parts A through E. None of these are going to be quick, so this is a little bit of a longer video, and I apologize for that. But that's just the nature of these kinds of problems. Okay, so we're given a hyperbola. How could you tell it's a hyperbola? Well, both variables are squared and they have different signs. One's positive, one's negative. In this case, the x is positive, so I know it's a left-right kind of orientation hyperbola, okay, rather than an up and down like the previous one was. The x1 is the positive one. And identify the center. Like, well, we don't have any x minus or y minus any business like that. So in this case, my center is going to be 0, 0. So we don't have to worry too much about that. So at least it's a little tame. Okay, they get to be a little bit worse as we go through. Okay, thankfully they let us check each one. The vertices. Now the vertices are going to be on the real axis. Okay, so in this case, it's going to be it's always from the center. Okay, the vertices are going to be from the center. Since the center is 0, 0, we don't have to worry too much about that. So when we go ahead and apply our method of intercepts, x squared over 36, setting y equal to 0. So it's y turns to be 0 right now. So we have x squared over 36 equals 1. X squared equals 36. So x is plus or minus 6. Okay, so we have plus or minus 6 units in the x direction from the center. Okay, so we're going to be at 6, 0 and negative 6, 0. Okay, those are our vertices. Okay, so we're going to be at 6, 0, 6, 0 and negative 6, 0. Okay, let us check that. All right, hooray. The foci. Okay, now the foci are c squared is equal to a squared plus b squared. Okay, and again, this is from the center in the direction of the transverse axis. Okay, in this case, in the x direction. Okay, and again, I usually provide this kind of thing to you on a quiz, so you don't have to memorize the formula for the foci. But all we're going to say is, okay, c squared is equal to a squared plus b squared. So all it's going to be here is 36 plus 64. Okay, so c squared is equal to 36 plus 64. I guess technically a squared is 64 here because it's bigger, but it's also on the minor axis, so might still be b. I don't remember exactly how your book has the notation, but yeah, we'll go with 36 and 64. That is equal to 100. So C is equal to plus or minus 10. Okay, so it is plus or minus 10 units in the x direction from the center. Okay, so I'm going to say my foci are going to be at 10, 0 and negative 10, 0. We're in the x direction, okay, and it's from the center. The center in this case happens to be 0, 0. Okay, so we don't have to add anything to the 0 plus 10. Okay, so we are 10, 0, and then negative 10, 0. Okay, we'll go ahead and check, and I'm glad they let us check each time, because otherwise you have to go to the end in order to figure out whether or not we're correct. Okay, there we go. Okay, the asymptotes. Okay, the way we graph a hyperbola, this is always what everybody's been waiting for, okay, is we have our center, we have our x goes out plus or minus 6, okay? So we are going to be at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6. Here is our vertices. Now, what if we set x equal to 0? Okay, for just a moment. Pretended the y part was positive, like as if there was something real in the y direction. There isn't, but let's just pretend that there would be. Okay. So here we go. So we have y squared. So we set x equal to 0. We have y squared over 64 is equal to 1. Okay. So y is equal to, y squared is equal to 64. Y is equal to plus or minus 8. Technically, You're right, it's a negative, it's a negative, it's a negative, it's plus or minus 8i. That's not real. If we had an imaginary coordinate axis we were graphing this on, we could do this. But since we are graphing on the xy plane, the real plane, we don't have this. This does not exist as a point. But we're going to pretend that it does. We're going to say 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And the part of drawing a hyperbola is we make a little box in the x part and the y part. Okay. We make a little box for the x part and the y part. And the way we draw our asymptotes, okay, all hyperbolas have asymptotes, okay, is what we're going to do is we're going to need some, go ahead and change my color. Okay, we're going to connect the diagonals of the box. We're going to draw a line through the box. Okay, pretend that's right. So what is the equation of this asymptote? What is the equation of these two lines? Well, it's easier than it sounds. Okay, first off, we have to figure out what our slope is. Okay, what is our slope? It's the rise over the run, isn't it? It's the change in y over the change in x. How much y did we change? Well, with y, we changed in the 8 direction, right? And then how much run did we have? That was over 6. So we can go ahead and cast out a 2, so that's going to be a 4 over 3. If we want to do it in the other direction, it's going to be a positive or a negative. So we might have the negative 4. Okay, so we have negative 8. Okay, that would be the rise of the, the big y part. That's going to be 4 over, sorry, 8 over 6 rather. 6, which is going to change to 4/3. Okay, so we have y equals mx plus b. I'm pretty happy that we have an m, 4/3. B is the intercept. Where is the y-intercept? Oh, wait a minute. It goes through the origin. So wouldn't b equal 0? So we're going to have y is equal to plus or minus 4/3 x. That is the equation of the asymptote here. Okay. To finish this problem off, to make it look like we actually drew a hyperbola here. Okay. What we're going to do is we're going to start from the vertices, okay, and we're going to draw our hyperbola. Let's make sure we're going in the right direction here. I think we're in the x is the real direction. It sure is. Okay, I just wanted to double check. We're just going to pretty much draw a hyperbola as such. Okay, and always remember that we have our graph here. The graph hugs the asymptote. So we're just going to go in, try to get as close to the asymptote as possible to hug the asymptote here, okay? And that is going to be the graph of our hyperbola here. Okay, so we'll go ahead and type in the answers that they want for our asymptotes here. Okay, y is equal to 4/3 x, and then y, oh, how about x instead of z? And y equals negative 4/3 x. You've got a little bit more work to do if you have a point that does not go through the center, or a point that goes through the center that is not the origin, but you will have a slope and a point. I think everybody who teaches algebra, or ever taught algebra or gone through algebra, will remember we have a point and a slope. So you're given point and a slope. Okay, we can go through and do some of these in other ways, but we have y minus y sub 0 equals m x minus x sub 0. Okay, the way I always say this, because a lot of my teachers happen to come from England, so we would say y minus y naught equals m x minus x naught. Plug in our point, okay, and then figure out what we're doing for our m. Okay. So we go through and do that, and then all we have is a different b at the end of this thing. Okay, so it's y minus y. It's n-a-u-g-h-t. Okay, when I teach intermediate algebra, a lot of students, I say y minus y naught, they'll think it's a philosophy class. It's like, well, why not? No, that's not the difference. It's not that y. It's not that not. Okay. So it's x minus x, not x, and a g h t. Okay. Not means it's all for not. It's all for nothing. Okay. So we would have a point and a slope. We would go through it and plug in our slope that we just found. We plug in our point, and then we get our b at the end of this thing. So we would recalculate for b. Okay, but that's all there is to that one. But I'll let that go, and we'll pick that up in the next problem so that we've got more and more and more to work with. But that's how you graph, and that's how you work with hold on, check. Okay, hooray. And then get the correct graph. Let's see what that's going to look like. So we've got some, how do we want to do this? We'll press this one and see what we get. Okay. So what is the center? We'll go ahead and put the center out here, X. Okay, and then we have the vertices. That's going to be at, I believe, 6 and -6. Okay. Placing the asymptote, and pretty much it's 4/3. So pick when x equals 1, right? Y is going to be 4/3. So the way you do that, if you wanted to go ahead and do this, so let's see, 1, 2, 3, 4, 5, 6, 7, 8 here, and I would want to be out here somewhere. So there's my 6 and 8. So that is a point that's going to be on the graph. That's how we made it. That's the corners of the box that we connected. Okay, and we'll go ahead and say that is our answer for that one. Okay, if you need to actually plot a point, you can always pick up the pencil, or pick up this tool, plot a point, and then drop the line on top of it this way. Okay, so there's another way around that. So we'll go ahead and check. Okay, hooray, and then we can go on and work the rest of this stuff. Okay, so thank you for watching the video, and good luck with hyperbolas. They're actually kind of fun. So good luck, and I will see you in the next video.